Computer science. We're going to talk about classes, objects, and object instances. When you write code in Java, the code you're writing is going to model a system. So what that means is you've got some big problem you want to solve, and you're going to break that problem up into objects. Programs are composed of objects. Each object does its own thing. Together, they'll solve your problem. Objects have behavior and state. The behavior is going to tell you what the object can do. Here we have a clock. The behavior of a clock is that you can set the time, you can get the time, you can set the alarm, you can get the alarm, you can ring the alarm bell, you can sleep the alarm. Those are things that this object, this clock, can do. It has attributes, and attributes are the things that this clock can remember. It remembers what the current hour is in the current minute. It remembers what the alarm's hour and minute are, and it remembers whether the bell is ringing or not. And the state is the value of those attributes. So the state of this clock is that the current hour is 10 and the current minute is 12. The current alarm hour is 10 and the current alarm minute is 10. And currently the bell is ringing. So that's the state of this clock. If you have multiple instances of an object, so you have multiple clocks, they're going to have the same behavior and attributes. So all clocks do the same thing and all clocks remember the same kind of data, but their state, the values assigned to their attributes, that's going to be different. So this clock up here has the time 10:12 and an alarm set for 10:10, and its bell is currently ringing. This clock down here is set to the time 12:15. Its alarm is set to 9:30, and currently its bell is not ringing. So they have different state, but their behavior and attributes are the same because they're the same type of object, but they're different instances of that type of object. If you have two different types of objects, so a clock and a wheel, then they're going to have different behavior and different attributes. A clock has time and alarms. A wheel has no concept of time or alarms, but the wheel, this wheel in particular, can hold balls. So you can add and remove balls from it, and you can spin the wheel. And its attributes are how many balls it has and whether or not it's spinning. So the behavior and attributes will make sense for that particular type of object. And they don't really cross over because different objects would obviously do different things. To create in your code, to create this concept of objects, we use classes. So a class defines the behavior and attributes of an object. So so here we got a clock, it's got some behavior, it's got some attributes. How do you tell the computer what that behavior is and what those attributes are? The class is like a blueprint. The computer uses the class to figure out how to create instances of these objects. So you would write a class that says, here's what a clock can do and here's what a clock knows. And hey, computer, I would like you to create a clock object for me. So it uses that blueprint to figure out how to create the object. And every time you create a new instance, it will use the blueprint again to make another copy of the object. Much like you can use one cookie cutter to produce a bunch of cookies that are all shaped the same way. The syntax for a class, what you actually have to write in your code to create a class, is very simple. This is it. Public class, name of the class, and some curly braces. That is all you need to write to define a new class. So this is what we call the class header. And the curly brackets show you what the class body is. The class header has the name of the class in it. When you name your class, you follow the same rules as you do for naming variables. So it's going to be made up of letters, numbers, and the underscore, and it cannot start with a number. The conventions for naming your classes are also similar to variables. You use camel case. The only difference is we capitalize the first letter of a class name. So variable names start with lowercase letters, class names start with uppercase letters. When you write code, you have to write your code in a file, right? You have to name the file you're writing the code in. The name of the file will match exactly the name of the class. So in this example, the class's name is name of class. So it's in a file called the name of class.java. So your code will always end with .java, but the name of the class the name of the file will match the name of the class. Exactly. Casing, and spelling matter. The rest of this header is just boilerplate. So public class is just always what your class is going to start with, and then you get to pick what you want to name it. Notice that there's no semicolon or parentheses at the end of this header. It's just public class, name of class. That's it. And then you've got your curly braces that go below it. So when you've got a program and you've split this program into a bunch of objects, you are going to write a class for each object. So in this example, we've got a clock class, a ball class, a cup class, a stapler, scissors, wheel. All of these will be in their own files, and they've defined their own class header with a body that will have some other code. We'll talk about what that other code that goes in the class body is. But every single object in your program has to be represented by a file that defines the class. When you define a class, so when you create a public class, whatever, you're creating a new type of data. So we've dealt with ints and doubles and strings and booleans. These are all types of data. When you write a file called public class clock, you are inventing a new type. This type is called clock. And so you can declare variables of that type: clock watch, clock wall clock, clock grandfather. And you can create new instances of those objects. New clock, they're all new clock. And when you say clock watch equals new clock, you get a watch, and which is a clock. And clock wall clock, you get a clock. And clock grandfather equals new clock, you get a clock. They're all clocks. They all do the same thing. But in this example, we've created 3 instances of this object using one class. The class is your blueprint that's used to generate these different objects. And this is called instantiating an object. When you say clock watch equals new clock, parentheses, semicolon, that is instantiating an instance of this object. So we have 3 instances of a clock object here. So once you've got your class, you actually want to start defining what are its behaviors and what are its attributes. Behaviors are represented by methods, and you write a method inside the body of the class. A method is made up of a method header and a method body. The method header has the name of the method. So here you can see name of method, and you would name this method something appropriate that describes what the behavior is. The rules for naming methods, again, the same as your naming variables: letters, numbers, underscore, can't start with a number. And our conventions are also the same as variables. It's camel case with a lowercase first letter. Methods always end with parentheses. These are called the parameter list. And sometimes there's nothing in the parentheses. Sometimes there's stuff in the parentheses. But there's always parentheses at the end of a method name. That's how you can tell the difference between a method name and a variable name. Since we follow the same naming conventions, they can look very similar, and you can tell the difference because a method is going to end with parentheses and a variable name will not end with parentheses. This part, public, this is the visibility of the method. It's pretty much always going to be public. Sometimes you might be reading some code where it's private, but I won't have you write anything that's private. So don't worry about that. Pretty much always write public for your visibility in your method header. Notice there's no semicolon at the end of the header. So every header that you write, if statements, while loops, class headers, method headers, there's never a semicolon at the end of the header. Your methods are defined inside the class body. So you've got your class header, then your curly brackets to define your class body. Your methods go inside of those curly braces, inside of the class, and they're indented. So remember, whenever you write code inside of a set of curly braces, you want to indent them a little bit. You can have as many methods as you want in a class, as many methods as you need. Each method will have a different name. And they're going to all go inside the class. You wouldn't write a method inside another method. So they're all kind of indented at the same level, and they go one after the other. The order of the methods doesn't matter, as long as they're all in the same class. To invoke a method, to call a method, to make an object do the thing that you described, you need an instance of the object. So here I'm going to make a clock object. I'm going to store it in the variable watch. And then I say watch.ringbell, parentheses, semicolon, and that's going to call the ring bell method. So you match up the name of the method, you find the method declaration in your class file, and then whatever code is in the body of that method, that will execute. In this example, there's no code here. I just put a comment, but you would write some code that would actually run when you invoke the method. So it's just whatever the name of the method is and those parentheses that match. That's how we know that's a method name. And you use dot notation to do that. So in the method header, there's one more piece I didn't talk about. This is the return type. So this says void. Void means this method does not return anything. So when you invoke the method, it will do some stuff, but it doesn't give you back any information. However, you can make a method actually return data by setting the return type. So instead of void, you put some type here, int, double, boolean, any type you've created with another class. And if you have a type, then you need a return statement, a return type, you need a return statement. So if this method says it returns an int, we need a statement in our code that says return some int value. And that's the answer that this method will return. The type of the value being returned and the type of the method have to match. If this method says it returns an int, then it better be returning an int and not some other type of data. So how do you invoke a method with return types? It's the same thing. So watch.getHour, in this case, the method's called getHour. Now, when you call a method that returns a type, you're going to want to store that variable or that value in a variable. So whenever you call a method that returns something, you want to declare a variable. In this case, I said int time, and then assign it the value of whatever that method evaluates to. The type of this variable in the code that's calling the method matches the type of the method, because this method is going to return an int. So I better be storing that data in an int variable. When you call a method that returns a value, that method call invocation down here evaluates to the value that the method returned. So in this case, the getHour method returns the value 7. So down here, when I say int time is assigned watch.getHour, I'm effectively saying int time is assigned the value 7, because watch.getHour evaluates to whatever this method returns. And in this case, it returns 7. Looking back at this method header again, the parameter list, these parentheses, you can put things inside the parameter list. So a parameter is a variable. So what you put inside the parentheses are variable declarations. So here, int x, I'm defining a parameter of type int called x. You can actually define multiple parameters. You separate them by commas, and you just keep defining variables. So int x, comma int y, comma int z. I've declared 3 parameter variables. All of them are ints. They don't have to be. In this case, they are. And they have the names x, y, and z. And then in your code, you can use these parameters to do whatever it is this method's supposed to be doing. In this case, I'm adding their values together, x plus y plus z, storing it in an int variable called answer, and then returning the answer. So parameters are variables that you are allowed to and should use in your code of that method. Parameters are automatically assigned values. So you should never, in your method, if you have a parameter called x, you shouldn't say x equals something. You shouldn't assign a value to the parameters. The computer is going to assign values to these parameters for you. So where do those values come from? When you invoke your method, so here I'm invoking the getSeconds method. Here's my getSeconds method. It has 2 parameters, hour and minutes. When I invoke it, I pass it some arguments, 3 and 15. Those arguments get assigned to the parameters when I invoke the method. So when I call getSeconds, the 3 gets assigned to hour, the 15 gets assigned to minutes. And then this code runs, and hour has the value 3, minutes has the value 15. It will do this math out. It just runs this code from top to bottom. It does the math out. It gets 11,700, which gets assigned to the seconds variable. And seconds is what this gets returned. So when I say int time is assigned watch.getSeconds315, watch.getSeconds315 evaluates to 11,700, and that's what gets stored in the variable time. So seconds gets assigned to time. Now notice I'm not using the same variable name here. I could, but you don't have to, because this variable name seconds exists in the scope of the get seconds method. It has nothing to do with this code in this blue box. And so the code in the blue box is really in some other file somewhere. It's using the clock class, but it's not in the clock class. So there's some other public class, whatever, that happens to have this code inside of it. And so it's in a completely different scope than this code. So it doesn't know anything about that seconds variable. So you don't have to, and there's nothing happens if you use the same variable name, but you don't have to. Those variable names do not have to match. The type has to match. So seconds is an int, time should be an int down here. Each time you invoke a method, the parameters get assigned new values. So here I've invoked the get seconds method twice. The first time with 3, 15, which assigned 11,700 to the time variable. Then I invoke it again, but this time I pass it the arguments 1 and 42. So it runs this code again, but this time hour is being assigned the value 1 and minutes is being assigned the value 42. Again, we don't write this in our code specifically. This down here is what's doing the assignment. When you pass the arguments, the computer will automatically assign the arguments to the variables, and then it will use those values to calculate this and get a number and assign that to time 2. And so that's when you write a method, we're solving a generic problem. We're not trying to solve the specific problem of if the hour is 3 and the minutes are 15, how many seconds is that? What we're trying to calculate is, given some number of hours and some number of minutes, what are the seconds? And now I can pick any number of hours and any number of minutes, and the computer will do all the work for me. That's the goal when we're writing these methods, is to solve a generic problem. And when we invoke the methods, we're saying specifically which version of this problem do we want to solve. And that's it for classes for now. There's a little more we're going to talk about, but for the basics for classes, so programs are composed of objects. You've got this big problem. You break the problem down into pieces, which we call objects. Objects have behavior and state. The behavior is your methods. We'll talk more about state later. The syntax of a class. So you've got your class header, public class, name of class. The file is named after the class, so the class name and the file name have to match. And we talked about the syntax of a method. Methods have a header and a body, public return type, name of method, parentheses with parameters inside the parentheses, return types and the return statement. So if your method returns an int, you got to return an int. If it returns a double, you have to return a double, and your parameters and your arguments. We talked about all of that. And that is computer science.